Hey guys, welcome back to 100 Days of Code. Today is day 4, and we're going to be focusing on randomization in Python, and we're going to be learning about Python lists. Now, randomization in any sort of programming language is really useful because if we want to create a game, if we want our program to do something different each time, then we need to introduce a little bit of randomness, right? So we're going to be looking at using the random module in order to achieve this. And by the end of today, you will have learned enough to be able to build this rock, paper, scissors game. So it starts out asking you, the user, type 0 for rock, 1 for paper, or 2 for scissors. So I'm going to go for 0 for rock. And it shows me using ASCII art that this is what I chose, rock. And then the computer chose scissors, and rock beat scissors, so I win. Now you can run this as many times as you want. If I choose paper and the computer chooses rock, then I win. If I choose paper and the computer chooses paper, then it's a draw. But if I choose paper and the computer chooses scissors, then I lose. So this is a pretty simple game, but we're going to get the computer to play this game with us. And we're going to do that by learning about randomization, lists, and a whole lot more. I hope you're ready. And once you are, then head over to the next lesson and let's get started. One of the first things I want to talk about is randomization. And this is a concept that we're super familiar with. Randomization is really important when we want to create computer programs that have a degree of unpredictability. Now, the biggest category of that is, of course, games, right? Can you imagine if you had to play Tetris and every single time the block that fell down was like predictable? You always knew that it was going to be a T and then it was going to be an L. Like, there would be no fun in that, right? So, how do we create this randomness for our programs? Now, in nature and in our everyday lives, it's really easy to create randomness. If you splash some paint on a canvas, that's going to be pretty random. If you take a look at the TV static from the analog TVs, that's also a whole bunch of randomness there. But when we're talking about computers, then these machines are what we would call deterministic. They will perform repeatable actions in a fully predictable way. So how do we wrangle these machines that operate basically on ones and zeros to get them to create some random numbers? Well, there's a whole bunch of maths that can be applied to create what are called pseudo-random number generators. And the one that Python uses is something called the Mersenne twister. And if you really want to read about it, then you can have a look on Wikipedia and take a look under the algorithmic detail. But to be honest, it's a little bit too much information for anybody, unless you're really interested in these types of number generators. But what I recommend though is a free video from the Khan Academy where they explain pseudo-random number generators, and it's really well produced and it tells you a lot of different aspects of pseudo-random number generation. So have a look at that if you're interested to learn a little bit more about pseudo-random number generators. We've talked a lot about randomness, but let's see it in action. Let's write some code and produce some random numbers. Head over to the Day-04 starting REPL and then go ahead and fork your own copy. We know that we want to get hold of some random numbers, but we don't really want to implement the Mersenne twister ourselves because it's horrendously complicated using lots and lots of maths and probably will take us months to write the code for. So how can we get random numbers? If you think about it, it's a little bit like searching for something in Google. The Google algorithm is horrendously complicated and it's taken them years and years to refine and perfect to such an extent where I think Google knows me better than myself, because when I search for something, it always gives me the most relevant results. And if you're questioning the complexity of the Google algorithm, just go to Bing and try searching for something and see how relevant the results are. So they have this super complex algorithm, which we're never going to get a chance to see, let alone understand. And yet, every day we're able to search things on Google and use this Google algorithm to get the things that we want, like the airspeed velocity of a laden swallow. Now we can do the same thing when we want to generate random numbers. Because this is such frequently needed functionality, the Python team have already created a random module. So if you head over to askpython.com and search for the Python random module, then you'll be able to see the documentation for this random module. And you can see that it contains a whole bunch of functions that you can use that allows you to generate random integers, so random whole numbers or random floating point numbers. So let's see how we can tap into this random module. In order to tap into the random module, we first have to import it. So we write import random. And now we're able to use this random module in our main.python code. We can start using the documentation to generate a random integer. For example, they show us in the code snippet here that we could generate a random integer by using the randint function, providing an a and b, and it'll return a random integer between a and b, including both of those numbers. And there's even a little bit of code snippet to show us how it's done. So this line of code generates a random whole number between 100 and 200, and including those two numbers. So it could be anything between those two numbers. So let's see if we can implement this in our code. Let's say that we want to create a random integer, and we use the same code that we saw in the code snippet. We say random, that's tapping into this module here, dot randint, and then we add a set of parentheses, and then we specify the start, comma, and then the end. So this is basically a range of numbers that we're specifying, any integer between 1 and 10. And now we can go ahead and print our random integer, just like that. And every single time I run it, you'll notice that I'll get a different number, or maybe sometimes the same, but it's a random number between the range that I've specified. Now, I've mentioned that the random module is a Python module. So what exactly is a module? Well, you've seen that we've mostly been writing our code all on the same page in a sort of script style, right? And everything just kind of gets executed from top to bottom. But sometimes your code will get so long because you're trying to create something complicated, and it's no longer possible to understand what's going on in such a large piece of code. What people will do in that case is to split the code up into individual modules, where each module is responsible for a different bit of functionality of your program. And if you have a complex project with many, many modules, then you could have collaboration on your project, right? Lots of people could be working on it, each person working on a different thing. Say if a factory was building a car, it wouldn't make sense for one person to build the entire car, from wheels to axles to the chassis. That's crazy. Instead, you have different people working on different modules, like the tire module, or the chassis module, or the engine module. And then once they put everything together, you end up with the final car, or in our case, the final program. So we know that the random module is a module that the Python team created to make it easier for us to generate our random numbers without needing to get into the complexities of all of the math that's required to generate pseudo-random numbers. But how can we create our own modules, and how do modules work anyways? Well, it's actually very simple. If you go ahead and click on the files icon, you can see we currently only have one file that we're writing in, which is main.py, the Python file. And the main.py is the entry point to our program. This is the file that will be executed when we run our code. Now, if I go ahead and click on this icon to add a new file, let's say I call it mymodule.py, and I create a new Python file. And inside my module, I'm going to maybe work on something else. Let's say I wanted to store the value of pi. Okay, I think that's all I remember. So I know the value of pi, and I want to be able to use it in my different programs. Now that I've created my module.py, well, now I can use my module wherever I want just by importing it. So I could import my module. And now down here, I can say, let's go ahead and print my module.py. And now if I go ahead and comment out this code and hit run, then you'll see we get that value of pi that got dragged in because I imported my module. But now we've got our code separated out into separate modules that are responsible for different things. And that is how the random module works as well. So I'm going to go ahead and delete all of this stuff relating to pi, but you can keep yours if you want to keep it for reference. Coming back to creating random numbers, we've seen how we can create random whole numbers, but what if I wanted to create a random floating point number? Well, it tells me how to do it in the Python documentation, and all I have to do is use the random module that contains the random function, and it will return a random floating point number between 0 and 1. But it's really important to note that in this case, it doesn't actually include 1. So it goes up to like 0.9999999, but not including 1. Let's go ahead and try that out. So we'll say random float equals random.random and then a set of parentheses. And this will give me output some sort of number in the interval between 0 and 1, but not including 1. So let's go ahead and see if it works. First, we print a random integer between 1 and 10, and then we print our random float between 0 and 1. And every time we run the code, you'll notice that we get different random numbers. Now, here's a question. This random function always generates a number between 0 and 1, and it has many decimal places. But what if I wanted a random floating point number between 0 and 5? How might we do that? Now, it's not as complicated as you think it is, and you'll be able to do it just by looking at the code you've got here. Have a think about it and see if you can come up with the answer. I'll go through it with you afterwards. Pause the video now and give that a go. All right, so we know that this random float can be anything between 0.0000 to 0.9999, effectively repeating, right? Now, what if we were able to multiply this random number by a number? Let's say that I multiply the random float by 5. Well, what if this random float was 0.1? Well, 0.1 times 5 would be 0.5. But what if the random float was 0.4? 0.4 times 5 would be 2. Or what if it was 0.9? 0.9 times 5 is 4.5. So effectively, by multiplying this random float by 5, I will end up with random numbers, but of course they're now floats, right? So it could be 0.000 ... all the way to 4.99999 and etc. etc. So this is how we can expand that range from 0 to 1 all the way to 0 to 5, but not including 5. So what can you do with random numbers? Well, if we think back to our love calculator that we made in the last lesson, it's kind of based on pseudoscience, right? Like, just because you have a certain number of letters that exists in the word true and love, it doesn't mean that you're actually going to be more compatible. I'm sorry to break anyone's heart out there, but if it's random anyways, then why don't we just use a random number generator, saving ourselves all of that trouble from counting T's and counting U's? We can instead just simply say love score equals random dot random int between 1 and 100, and then go ahead and just print your love score is, and then let's insert our love score and turn this into an F string. Let's print that. And you can see that we're getting a different love score every single time I run this code. It's between 1 and 100. And who can tell that this is any different from the previous method, right? So we can use our random number generator for this. We can use it for creating a dice or flipping a coin, or we can use it in games that we create. If you head over to the next lesson, I've got a code challenge for you where you're going to be building a program in order to pick from heads or tails and help the user out when they don't have access to a coin. For all of that and more, I'll see you on the next lesson. Now, if you head over to the course resources, you'll be able to find a link to this first code exercise. And the idea is that you're going to create basically a virtual coin toss program so that when you run the code, it should give you tails or heads depending on which random number was generated. Try to use what you've learned in the previous lesson to complete this challenge. So pause the video now and give that a go. All right, let's go through the solution together. So first, make sure you forked your copy of the exercise so that it's under your own username. And then we're going to go to main.py where we always write our code. Now, in order to use the random module, we first have to import it. So the module is called random. So we write import random. And now using the random module, we can now tap into randint, which will generate a random integer between a starting number and a ending number, and it's inclusive of both numbers. So let's call this the random side. And using this random side, we can use an if statement to check, well, if the random side that was generated is equal to 1, well, in that case, that means we should print that we generated heads. So that's the part of the coin which normally shows a person's face. Now we can use else to catch the situation where we get a 0, and in this case, we'll print tails instead. So that's all there is to it. And of course, as always, there are many, many ways that you could solve this challenge. And if you're creative, or if you looked around and you found a different way, then that's great. But this is how we would do it using what we learned in the previous lesson. So how did you get on with it? If you got stuck, if you forgot how to do certain things, or if some parts of your code didn't work, or if you had errors, then this is the time to go back and fix it so that you actually understand what's going on and we can proceed. So once you're done, head over to the next lesson and we're going to learn about Python lists. Hey guys, today I want to talk about something that is really, really important and you're going to use many, many times in the future. And this is the concept of the Python list. And the list is what you would call a data structure. What does that mean? Well, it's just a way of organizing and storing data in Python. Now, we've already seen ways of storing single pieces of data, and that was done through the simple variable, where we just said A is equal to 3 or B is equal to hello, but that's just storing one piece of data, right? Be it a number or a string. But sometimes you might want to store grouped pieces of data, data that has some sort of connection with each other. For example, if you wanted to store all of the names of the states in the US, then it doesn't really make sense to store them all individually because they kind of belong together, right? They have a relationship to each other. So it would be nice if you had a variable that was called states in the US, and then you would be able to store all of the names of the states together in one variable. Now, in other cases, you might also want to have order in your data. So, for example, if you were storing all of the people in a virtual queue, then you want to be able to keep hold of the order in which they joined the queue. You don't want to let the last person somehow skip the queue because you don't have a good data structure, right? This is why we need to learn about lists. And lists look pretty simple. It's just a set of square brackets with many items stored inside. And those items can be any data type. They can even have mixed data types, like you could store strings together with numbers, or a set of booleans. It doesn't really matter. But what does matter is the syntax. In Python, lists always start with an open square bracket, like this, and a closing square bracket, like this. And then in between, you have your items separated by a comma. So pretty simple. In order to store it inside a variable, then it's the same way as we've done before. The only difference is the right-hand side of the equal sign. This is the list data structure. If we stored a bunch of fruits, for example, then it might look something like this. Cherry, apple, pear, separated by a comma inside a set of square brackets. Let's take a look at this using real code. Now, I'm going to go ahead and comment out the code from our previous lesson on randomness, and you can do the same if you want to keep a note of the previous code and use it as sort of a live textbook where you can comment out the code or comment it back in order to see how it works, or you can delete it. It's totally up to you. Now, let's say that I wanted to store all of the names of the states of the US. Previously, without knowing about this list data structure, we might have written state 1 equals Delaware, state 2 equals Pennsylvania, and so on and so forth. And we would create as many variables as we have states. But now that we know about lists, then we can just create a single variable and we call it states of America. And now we can create a list by creating a set of square brackets. And inside those square brackets, we add our items. So again, the first item is the state of Delaware, which is going to be a string. And then we've got Pennsylvania, etc., etc. And we can continue this list just by adding commas, adding a piece of data, adding another comma, adding a piece of data. And this way, we end up with a list data structure. Now, one of the interesting things about the United States is that the different states in the US actually joined the Union at different times. You can actually head over to Wikipedia and watch this little animation and see each state join the Union and at which time point they did so. The order of this data is now kind of pretty important. Because if we wanted a list of US states that are in the order that they joined the Union, then the order in which they're stored in our data structure is now also immensely important. And this is another thing that you get with lists. You can use a list to store many pieces of related data, but they also have an order, and the order is determined by the order in the list. So this is the first piece of data, this is the second piece of data, and when you store it inside the variable, that order is not lost, and you'll be able to use it later on when you need the list. Here's a list of states of America ordered by the date that they joined the Union. And you can see that if later on I decided that I wanted to know which was the state that joined first, then I can print this variable, States of America. I can add a set of square brackets, and then I type 0 as the index of the piece of data I want to pull out from my States of America list. So now if I go ahead and run this code, you can see it prints out Delaware. And if I keep increasing this number, you can see that it's going through my list in the order that it was saved. So you might be wondering, that's kind of weird that you typed 0 and you got Delaware, right? Surely Delaware should be the first item in the list. Well, this is a kind of peculiarity with computers and programming languages. You'll tend to find that programmers start counting from 0. So Delaware is at 0, Pennsylvania is at 1, New Jersey's at 2. And this idea might seem a little bit weird at first. Why is the first item at position 0? But if you think about that index number, that 0, 1, or 2, instead of being the position, actually being an offset or a shift from the start of the list. Well, then, in this case, cherry is right at the beginning of the list, so it has a offset or a shift of 0. But apple is shifted from the beginning by 1, pear is shifted from the beginning by 2, and so on and so forth. Then it kind of makes more sense that the first item in the list is at the beginning of the list, so it has no offset, so it's 0. And you'll find that in many programming languages, there are similar data structures to lists, and this is how they're usually ordered, starting from 0 and then adding by 1. Now, you can see that when you want to get hold of a particular piece of data stored inside a list, what you do is you get the name of the list, and then you add another set of square brackets. So whenever you see square brackets, you should be thinking to yourself, oh, this might be related to a list. Because when you create the list, you use square brackets. And when you try to get items out of the list, you also use square brackets. And then inside the square brackets is where you put the index or the offset of the item that you want. So if we want a New Jersey, it's offset from the beginning by 1, 2. So now this part of the code is equal to New Jersey. And we could, if we wanted to, save it into another variable, or we could simply print it as we did before. Now, in addition to using the positive index, so say 0, 1, 2, 3, you can also use a negative index. So if I wrote -1 or -2, then it actually starts counting from the end of the list. So if I wrote States of America, square brackets, -1 as the index, then I get Hawaii. -1 is the last item in the list, because you can't really have -0. That's not actually a real thing in maths. Now, as I continue and I go to -2, then that's Alaska, -3 will be Arizona, and so on and so forth. So you can have positive indices and negative indices. But so far, we've only been pulling things out of our list by using our square brackets and the index. But you can also change the items in the list using very similar code. For example, if I decided that Pennsylvania is actually not spelled Pennsylvania, and I wanted to change it to Pennsylvania, then I can simply write my code like this. I get hold of my list, and then using the square brackets, I get hold of the item at index 1, which is this one, and then I set it equal to a new piece of data. So now if I go ahead and print my States of America list, you'll see that the list looks a little bit different now. Instead of Pennsylvania, it's now Pennsylvania. So you can alter any item inside the list pretty easily using this kind of syntax. You could also add to the list if you wanted to. So for example, if you wanted to add an item at the end of the list, which is what happens most commonly, right? If you had a list of people who are queuing in your shop, then every subsequent person usually gets added to the end. If you have a new state that joined America, then it's probably going to be added after Hawaii. How do we do that? Well, we can write the name of the list, and then we use a function called append. And append will add a single item to the end of the list. So let's say that Angela Land is joining the United States of America. So now, once I've appended Angela Land to the end of my States of America list, and I print the States of America, you can see there it is added right at the end. Now, there's actually a whole load of other functions that you can use in addition to append, and you'll find this on the documentation for Python. In addition to the append function that we saw just now, where we add an item to the end of the list, there's a whole load of other functions that you can use with lists. For example, you can use the extend, which adds a whole bunch of items to the end of the list. And in this case, what you're actually adding is going to be a list. So I would be creating the list using square brackets and then adding my items in here. And now what's happening is I'm extending this States of America list with this additional list. So now if we print the States of America, you can see that these two items that used to be inside the list have now been added to the previous list, and it's now extended it by two more items. But the important thing is you don't have to memorize these functions. That's the whole point of documentation and why we have Google, because there's too much information in the world for you to memorize. And it's a very inefficient way of learning. And if you tried to memorize every single method, it's not impossible, but it means that you don't have space in your brain for the important stuff, which is how things work. How do you actually use it to do what you want it to do? So what I recommend when you come across a new thing, such as the list data structure, is to just have a look through the documentation, read through it, and see what are the possible things you can do. And once you've got the idea of this is possible, then the next time when you need to use it inside your code, you'll know, I remember, this is possible. And all you have to do is just be able to use Google to find the exact bit of the documentation and then implement it. Programming is kind of like an open book exam. You shouldn't need to memorize anything. You should spend your time trying things out and try to get things to work instead. Now that I've introduced you to this new data structure, the mighty list, it's time for a code exercise to see if you can use it in practice. So head over to the next lesson and give the challenge a go. So the code challenge that you're about to do comes from a really interesting phenomenon that you might find in London. I live in London and it's well known as a big financial district. So when you head over to the city or the financial area in London and you go into a restaurant, you might see a strange thing happen. You might see a whole bunch of people in suits who look very much like the financial banker types. At the time when they actually need to pay the bill, you see everybody pull out their business cards and put it into a bowl. So what's actually going on here? A friend of mine told me apparently there's this game that the rich banker types play where it's kind of like Russian roulette with the bill. So everybody puts their business card in and the person's card who gets picked out has to pay for everybody's bill, which is kind of crazy, but then again, it's finance. So in today's code challenge, this is what we're going to replicate with code. Head over to the course resources and click on the coding exercise to bring it up. Now go ahead and fork your own copy of it so that you can make amendments. Now, the idea is that once you've completed the challenge, you should be able to type in a whole bunch of names as an input with a comma and a space separating each name. And then the code will pick a random name from the ones that you've given it and tell you who is going to buy the meal. Now, there's two lines of code here that you might not have seen before. Now, this is something called split, and this allows you to split a string into separate components based on some sort of divider. So in this case, notice how it says hello, comma, from, comma, as Python. Now, if we use the split on this string, then it will divide it up into a list and separate out all the words that are divided by this split character, which is the comma. Now, similarly over here, when we give the input, it's going to be in the format like this. Everybody's names separated by a comma and a space. So now, if we use the split on a comma and a space, then it will take out the comma and the space and it will put everything else as separate items inside a list. So what I recommend doing before you get started writing the actual code is to test it out. So print out what names actually looks like. So if we go ahead and run this code, and then we type a bunch of names separated by a comma, so Angela, comma, space, Ben, comma, space, Jenny, and then hit enter, then we hit the line where it prints names. Now names, as you'll see, is now a list with all the names that I typed in. And while previously they were separated by a comma and a space, they are now all individual items in a list. The idea is that you've got all of these items inside a list. How can I pick a random one out of it using a random index based on the number of items in the list, which of course can change? And then how can I get a random name as the output and then print so and so is going to buy the meal today? So have a think about it, have a pause, and then see if you can complete the challenge. So now that we've got the list as a starting point stored inside names, how can we go about generating a random name and picking it out of the list? Well, we know that we can pick a item from the list by adding a set of square brackets and then a index number. So in this case, it should print the first item out of the list, which is going to be just the word Angela. And I can run this to prove this to you. You can see that names is a list of all the names, Angela, James, Ben. Names at position 0 is Angela, the first item. Now, how can we get a random number to replace that number 0? Well, we could use our random generator. Let's go ahead and import the random module, and we can say random.randint, and then we can specify the start and end. So the start is probably going to be 0 because that's where we start counting with our lists. But what is the end? Well, the end should be the position of the last item. But how can we know that position? What is that X going to be? Well, what if we got hold of the number of items in the list? So do you remember how previously we learned about the len function? Well, the len function can be used to get the number of elements in a list or the number of characters in a string. And if you take a look at this Stack Overflow question, then you'll see it in action. All that we have to do to get hold of the number of items inside this names list is to write len parentheses, and then inside we put names, and now we can either store this or print this. Let's go ahead and first print what the value of this is going to be. Let's go ahead and comment out this line of code and then run our code and then give everybody's names separated by a comma, hit enter, and you can see that this line of code has printed 3. So the length of my names list is 3. So now that we've gotten hold of that, then we can probably use that number that comes from this len function inside our random generator, because we know that we can use this to get the total number of items in list. So in this case, that would be 1, 2, 3, 4, 5. This last item is not at position 5 though, right? It's at position 0, 1, 2, 3, 4. So we always need one less than the total number of items. And the range of random numbers we would want is num items minus 1. Now this line of code will allow us to generate random numbers between 0 and the last index. And I can store that inside a random choice variable and print my random choice. So if I run the code again and it prints 1 this time, but the next time it might print 0 or 2, because those are all the possible choices for a 3-item list. Now we can use that number to actually get hold of a particular item in our list of names. So we can say names, square brackets, and then we're going to use the random choice to get hold of the random item. And then we can go ahead and save this as the person who will pay. And we can print person who will pay plus is going to buy the meal today. So now let's go ahead and run our code again and then give everybody's name separated by a comma. And then it says James is going to buy the meal today. And now we know that we've completed the challenge. Now, you'll notice that in the instructions, I told you that you're not allowed to use the choice function. And the reason for this is because if you search as Python and you search for the random module and you scroll down, you'll find that you can actually generate random items from a sequence, such as a list, by writing random.choice. And it will actually pick an item from that list. So let me demo what our code would look like instead. Instead of needing all of these lines of code, all we have to write is random.choice, parentheses, and then we put our names list inside. And now it will do exactly the same as before, but with far less code. But this, of course, doesn't test whether if you've understood how indices work with lists and whether if you're comfortable with the idea that the last index is actually one less than the total number of items because we start counting from 0. I've made it a little bit harder than it needed to be, just to see how good a grasp you have on lists. Now, I hope that you managed to complete this challenge. If not, don't worry, go back to it and see if you can replicate the logic that we talked about just now. And if you really struggle visualizing what these lines of code is doing, then you can always pass it through Thonny and use the debugger to step through it one step at a time and see what's happening at each stage. Now, on the next lesson, we're going to see some more advanced parts of lists in action, namely how to nest lists inside other lists. So for all of that and more, I'll see you on the next lesson. Now, when you're working with lists, one of the most common errors you'll come across is something called the index out of range error. In fact, by this point, you might have already seen it. Now, what does it mean though? Well, let's take our states of America and let's delete the line where we added Angela Land and Jack Bauer Land. So we go back to the original. And you might remember that there are 50 states in America, but if you don't, because you're a programmer, it's as easy as writing len and then passing over the states of America, which will print 50. So now that we know that there are a total of 50 items in this list, and remember, because we start counting from 0, Hawaii is actually at index 49. So if we print States of America and then we try to get the item at 49, we hit print, you'll see that we get Hawaii printed. Now, what if we went one beyond that? What if we tried to get the one at index 50, somewhere out here? What do we get instead? Well, we get an error. It's called an index error. And this is because it's beyond Hawaii and there's nothing there, as we can see with our own eyes. But when you're working with large lists and you're not always looking at the data, then these errors can be a little bit more confusing. Very frequently, when you're working with lists, you'll end up with an off by 1 error. So it's unusual that you'll try to get something at index number 90 because that's just way beyond your list size. But very frequently, you might end up in a situation where you have some sort of value, say number of states equals len, and then we pass over the states of America. So this is going to be equal to 50, and then we pass that inside here as the index num of states, and then we hit run, and we get the same error, right, on line 16, where we try to get hold of this index in this list. It's again, list index out of range. And this is an off by 1 error because all we need to do is just simply minus 1 so that 1 becomes 0 and 50 becomes 49. And then we get rid of that error. Now, it might be easier if we work with something a little bit simpler. Recently, I was reading online and I came across the so-called dirty dozen, where the environmental working group, a bunch of people, crunched through a whole lot of data, probably using Python, and they released their dirty dozen, a list of the fruits and vegetables that have the most pesticides. And it's kind of crazy that they actually washed and peeled all of these foods and then tested them for pesticides. And the list looks something like this, where strawberries are apparently one of the worst offenders for pesticides. So let's create a list of the dirty dozen. But you'll notice that some of these are fruits like strawberries, apples, and other ones are vegetables. So how can we use our lists to still keep them inside the same sort of container, the dirty dozen, but somehow separate them out into fruits and vegetables? Well, we could just simply create two lists, fruits and vegetables. But these two lists kind of have a relationship, right? They're kind of related because they're all on the list of high pesticide foods. So how can we have lists within a list? Well, that's what's called a nested list. Instead of our original dirty dozen, we could create a new list called dirty dozen, and we set it equal to a list that contains two lists. It contains fruits and it contains vegetables. So now what effectively has happened is we've inserted this list inside here, and then we've inserted this list inside here. So we now have a list that contains two lists. And if I go ahead and print out this list, you'll be able to see its structure. And it looks like this. You'll notice that there's two brackets at the beginning and at the end. And the reason is because this is one list, this is another list, and this is also a list. So this is yet another way of using lists and just showing you the flexibility of this particular data structure. It's something that you're going to use a lot when you're writing Python code. Now that we've talked more about index errors, how to fix them, and also nested lists, you're ready to go to the next coding challenge. So head over there and give that a go. Alright guys, it's time for another code challenge. So head over to day 4.3 treasure map and take a look at what is happening here first. Notice how we've created three lists here for you, row 1, row 2, row 3, and they've got some blank tiles in here. And these were just created with emojis. So if you just search for emoji and you come across the list of emojis, then you can simply just copy and paste them right into your code like that. So depending on whether if you're on Windows or Mac, you'll see the emojis display a little bit differently, but it doesn't really matter what it looks like. All that we want to do is to create almost kind of like a chessboard or a map like this. So we have 3 rows, and then we create another list that includes all 3 rows. So this map is actually a nested list because row 1 is a list, row 2 is a list, etc. And it's all put inside a list. Then we go ahead and print it so that we add a new line in between each row. And the final outcome looks something like this. So if we go ahead and just run the code, you'll see that we have almost like a chessboard, or essentially a 3x3 square, right? And the sort of way that we're going to navigate this map is by using some indices. So we're going to say that this is column 1, 2, and 3, and this is row 1, 2, and 3. Now, if you've ever played chess, or if you've played chess with a computer, you'll know that the different moves or the different positions are often mapped out using letters and numbers. So, for example, if you wanted to move to this square, then it would be B4, right? Or if you wanted to move to this square, then it would be H3. In our sort of 3x3 map, the way that we navigate is first by specifying the column, the horizontal column, and then we specify a number for the row. So for example, if I wanted to place my X marks the spot of my treasure, at this particular position, then it is 1, 2 on the horizontal, so column number 2, and then 1, 2, 3, row number 3. So I would write that as 2, 3. And if I wrote 3, 1, then it means I want column 3 and row 1. So I want to mark the spot here. So when you run the code, the idea is that you should be able to specify a location using that 2-digit system, and you should be able to place an X at that location. Now, in order to do this, it will need you to review what you know about lists, what you know about using the index to change a particular item in a list, which you saw in previous lessons. And the added complexity is here we actually have a nested list, so lists inside lists. So have a play around with this code, and that's the really important word. It's play, right? There's nothing that could possibly go wrong. Just try some different lines of code, try doing some different things, and see if it actually prints out the outcome that you want, where when you specify a location, that's the place that gets marked with a capital X. Pause the video and try to give this challenge a go. All right, so let's try and solve this. So notice how at the very bottom of the code, I've got another print statement, which is going to show us the outcome of whatever code it is we write here. The first thing we probably want to do is get hold of the input position, right? We know that input always takes in a string. So even if we typed 23, that's not going to be the number 23. It's going to be the string with 2 and 3 inside the string, something that looks like this. Now we can use what we've learned in previous days and previous lessons to split that string so that we end up with a horizontal position and a vertical position. That way we know, well, which column are they interested in and which row are they interested in. In order to do that, we tap into this position. And in order to get the horizontal, which we mentioned is the first digit, then we go ahead and get the 0th item out of that string. Remember, the string looks like this. So the 0th item out of the string is this one. And then the vertical is going to be the one at position 1. Now, of course, these are still strings as they stand right now. We've just split up this 2-digit string into horizontal and vertical. So this one, if 22 was the input, would be equal to 2, and this one would be equal to 3. Now, once we've gotten hold of the horizontal position and the vertical position, then we can go ahead and start specifying positions in our list. So we know that we've got our map, right, which is here, this nested list. And remember that it contains 3 rows. Now, if we wanted to get hold of the first row, then we would write map 0. If we want to get hold of row 2, then we would write map 1 and map 2 to get row 3. Now, remember that this is the vertical position. So this is the one that we're going to be getting hold of. Or in this example, it would be the number 3, right? So we could say map passing in the vertical position. But there's just one problem, and I'll show you if I go ahead and print this map at the position vertical. Let's put in the example number, which is 2, 3, and you'll see that the problem is that list indices must be integers, whole numbers, not a string. Remember that we said these are still strings, so to convert them into integers, we use that integer conversion that we've seen before. So now both the horizontal and vertical are integers, and we can run this code again and see how it performs. Let's put 2, 3 in there. And we end up with the error that we learned about in the last lesson, which is index error. So it's out of range. So what's going on here? Remember that in our example, where the number is 2, 3, well then the horizontal is the first number, so it's going to be 2. And then the vertical is going to be the second number, so it's going to be 3. And then we try to get hold of that particular row from our map. Now, if we pass 3 into our map, then you can clearly see what's going to happen. There's 0, 1, 2. There is nothing at position 3. There is nothing that has been offset from the beginning by 3, right? So that doesn't exist. And this is why we get our index out of range error. So what do we have to do instead? Well, we have to remove 1 from it to shift it to row 3, because that's really what we're interested when we're writing this here, right? We can do the same by substituting the 3 with vertical, so it'll work with any number. And now if I run my code again, type 2, 3, then you can see that I get no more errors. And it actually prints out a row that I've selected, which is row 3. Now, you can of course change these just to make it a little bit more clear to yourself what's actually going on here. Let's type 23 again, and you can see that this is what's being printed. Now, the next step is, once I've gotten hold of row 3, how can I get the horizontal tile? So the horizontal tile we're interested in is the second one, so it's actually this one. So when we write 2, 3, then it's this tile that we're interested in. So instead of printing out this row 3, which we selected by writing this code, we can save this as the selected row. And then inside the selected row, we can get to the tile at the horizontal position that was specified. So we could say selected row at the position of the horizontal -1. This works the same way because our numbers that we're entering here, row 1, 2, 3, or column 1, 2, 3, they don't start from 0, so we have to shift it down by 1 in order for it to work. So now once we've gotten hold of the selected row using the vertical, and then the selected tile using the horizontal, well, now we can actually change it. And the thing we want to change it to is a capital X. So now if I go ahead and run my code, then you can see it works just as the instructions want it to work. So here's our map. Where do you want to put the treasure? If I write 2, 3, then it will put the treasure on column number 2, row number 3. Now if I run this code again and I say, well, now I want to put it in column number 1, row number 3, then there it is. So this is now working for any possible combination that we come up with, as long as we're using the coordinates of our map. Did you manage to get it right? And did you write the code in a different way, perhaps? Because there's many ways of doing the same thing. And the easiest thing that I can spot right now is, what if we didn't need to separate this out into 2 lines? Instead of creating a selected row, we could simply just tag on this at the end, get hold of this particular row from the map, and because this is going to turn into a list, namely one of these, well, then we can simply just use another square bracket to specify the column. And then we set that tile to a capital X. So depending on which format you find easier to understand, you can keep your code either like this or like this. This is obviously a lot more succinct, but it depends on whether if this logic actually makes sense to you. So have a think about what happened here, and if you didn't manage to complete the exercise, then try to give it another go now. In the next lesson, we're going to tackle our final project of the day. So once you're prepared and once you're happy that you've understood everything that we've covered so far, then head over to the next lesson where we're going to get started building our rock, paper, scissors game. Alright guys, so now that we've loaded up all the knowledge that we need into our brains, it's time to tackle the final project of the day. And as I showed you in the beginning of the day, it's a rock, paper, scissors game that we can play with the computer. So the game starts out by asking you to type 0 for rock, 1 for paper, or 2 for scissors. So let's go ahead and type 2 for scissors. And then it's going to show you a graphic of your choice, scissors, and then the choice the computer made, which is rock. And of course, rock beats scissors, so you lose. What this game boils down to is some way of randomly making a choice between rock, paper, or scissors, and then comparing that choice that the computer randomly generated against your choice, and then based on the rules of rock, paper, and scissors, determining whether if you won, you lost, or whether if you had a draw. While I was looking around, I actually came across the World Rock, Paper, Scissors Association. And they have the official rules listed of rock, paper, and scissors. If you're not familiar with this game, it might be worth checking out this website. Here are the 3 shapes of rock, paper, and scissors. And then the rules are that rock wins against scissors, scissors wins against paper, and paper wins against rock. Having all of this in mind, head over to Replit/@brewery/rock, paper, scissors start and go ahead and just fork the starting project. Now you'll notice that in the starting project, I've already got the ASCII art for rock, paper, and scissors in here, and they're each saved to a variable. So what that means is that you can start out by just having a go at printing out, let's say, rock. And remember that these are variable names. They're not strings, so they don't need the double quotes around them. So let's run that, and you can see what we get printed is the particular ASCII art that I chose in my print statement. So this is already yours, but as you'll notice, there's no other logic that I've provided you. And you are going to rely on what you've learned in the previous days, and most importantly, what you've learned in today's lessons to be able to complete this challenge. And it's worth comparing the outcome against the game of rock, paper, scissors that I'll link to. There's a couple of things to think about, namely, how are you going to decide who won or who lost? How are you going to get the computer to choose a random shape, rock, paper, or scissors? And how you actually get this game to work in the same way that is demoed in this final version. I'm going to go quiet now, and I'm going to let you pause the video, and I want you to spend at least 10 or 15 minutes working on this. And if you get stuck, just try some things out, or maybe watch some of the previous videos in the day and just try to give it your best go and do a lot of struggling. Hopefully you're going to succeed, and once you're done, head back over here and I'll go through the solution with you. So pause the video now. Alright, so we know that we've got all of this ASCII art, but for the moment, I'm just going to start off by pinning down the basic logic of this game. And it's really helpful for you as well if you start thinking about breaking down the larger problem, which is making the rock, paper, scissors game, into smaller problems that you can solve, like generating a random number between 1 and 3. So we have some sort of proxy for rock, paper, and scissors. And then maybe thinking about putting down the logic. Well, if the computer chose scissors and I chose paper, then I'm going to lose. Or if the computer chose rock and I chose paper, then I'm going to win. And putting that down on a flowchart using draw.io or something like that can make this challenge a lot easier as well. But without further ado, the first thing I need to do is to produce a user choice. Now, this is going to be the one that the user chose when they typed in a value. And in order to get the value from them, I'm going to need to use a input. And inside the input, I'm going to put the following prompt, asking the user, what do you choose? Type 0 for rock, 1 for paper, or 2 for scissors. Now, once I get hold of this input, hopefully, if the user is following my instructions, they're going to type some sort of number, either 0 or 1 or 2. Now that I've gotten hold of what the user wants to choose, the next thing to do is figure out what the computer is going to choose. So I'm going to make another variable called computer choice, and I'm going to generate a random number. So to do that, remember we have to import the random module, and then we can start using it to generate random whole numbers by using random.randint, and then the range is going to be between 0 and 2. Because this is what I asked the user to do. Type 0 for rock, 1 for paper, 2 for scissors. So the computer is also going to choose between 0, 1, or 2. Now that I've got the computer choice, I'm actually going to just print it out for now. Instead of printing out the actual shape, I'm just going to print out the number. So computer chose, and then let's go ahead and add a F string. And of course that requires the F in front of the string. So now if we just play the game as it is, remember that testing your app while you're developing it is really, really good practice. It picks up on the bugs that you make along the way instead of waiting until the end when you've done everything and then it doesn't work and you have to untangle all of the lines of code. At this point, I've already realized that it's actually not so great getting the user to type on this line. What I would much rather is to start a new line for them to type their answer on. So if I run the code again, then it should look a bit like this. My prompt is now here. So I'm going to choose 0 for rock. And then it tells me that computer also chose 0. So in this case, this would be a draw. But if I played this game again, you can see that the computer is probably going to choose something different. So I chose rock again, the computer chose 1, which is paper. So now we can start thinking about how do we compare these two choices and how can we define the logic of rock, paper, scissors. So I know that paper beats rock, scissors beats paper, and rock will beat scissors. So if 0 is rock, 1 is paper, and 2 is scissors, then 2 beats 1 and 1 beats 0. So that's very simple for us to check in terms of using if statements, right? We could simply just check, well, if the computer choice is greater than the user choice, well, then this probably means that the computer wins. But this is not true in all cases, right? Because if the computer chose 2 for scissors and the user chose 0 for rock, then the user should win rather than the computer winning. So we actually have some exceptions to this rule. How can we catch the exceptions before we go down to this level of generalization? Well, we could, instead of using this as an if, we use this as an elif, and we create another if statement which says, well, if the user choice is equal to 0, so if the user chose rock, and the computer choice was 2, well then this means that in this case, the user actually wins. Now, if we're thinking from the perspective of the user when they're playing this game, then they don't really care if the computer won or the user won. They want to know, did they win or did they lose? So let's change this wording a little bit. We'll say, instead of user wins, we'll say you win. And if the computer wins, then we'll say you lose. So now if we run our program and test it out, so let's say I'm going to type 0 for rock and the computer chooses 2, but we actually get an error. It tells us that the greater than comparison is not supported between instances of int and string. What's going on here? Well, remember that we get our inputs as a number, but the input is always going to be a string. So we want this to be a number, then we're going to have to wrap it inside an int. So now we turn it into a whole number. Now, this might be a good point to address, well, what should happen if they typed something that wasn't 0, 1, or 2? What if they typed 34? Well, then naturally, they should probably lose, right? So we can add an else statement addressing this situation. So we could say, else, we just print, you typed an invalid number, you lose. Cool, so that sorts that out. Now let's run our code again and see if it works. What do you choose? Type 0 for rock. I'm going to choose rock again. Computer chose 0, and it tells me that you typed an invalid number. Well, actually, 0 is not an invalid number. So what's going on here? Well, it's because it didn't fit this criteria. So I had 0, computer had 0, and it didn't fit this criteria because 0 is not greater than 0. So it basically defaulted to the final else statement. But what's actually happening here is that was a draw. Computer chose rock, I chose rock. That's a draw in the official rules of rock, paper, scissors. So how do I catch that? Well, I could create another elif statement which says, well, if the computer choice is equal to the user choice, well, then we're going to print it's a draw. Now let's test our app again and see if there are any other situations where our code is not behaving properly. I'm going to choose rock again. Computer chose rock as well, and I get it's a draw. So that's pretty good. Now, if I choose 0 and the computer chose 2, then this is going to be the statement that gets triggered and I win. So that's pretty good. Now, what if I chose 2 for scissors and the computer chose 0? Well, in this case, rock beats scissors, so it should actually say I lose. But instead, it says you typed an invalid number. So it defaulted to the else statement again, because this particular situation is not caught by any of these statements. So what do we have to do instead? Well, we actually need another elif to say, well, if the computer choice was equal to 0 and the user choice was equal to 2, well, this means that rock beats scissors, so I lose, and the computer wins. Now, the final one that we need to catch is this case. If I type 1 for paper and computer chooses 0 for rock, it again defaults to the else statement. Whereas in fact, in this case, it should tell me that I won. So what's missing here? Well, it's the partner to this particular statement. If computer choice is greater than user choice, then I lose. But on the other hand, if the user choice was greater than the computer choice, then I actually should win. So now the final thing we might have to fix is this else statement now actually never gets called, because this is what happens. So let's say that I choose 456. It tells me that computer chose 2. I win. What's happening here? Well, it's actually this particular line that's being carried out. User choice is greater than computer choice. This is not what we want. We want it to default to you typed an invalid number, you lose. So we can't actually just use else in this situation. We actually need to provide a condition. We're going to use elif to check if the user choice is greater or equal to 3. Now, the computer will never choose anything other than 0, 1, and 2, so we don't have to check that one. But the user could choose something above 3 or below 0. So we can use an or statement to catch this. Or if the user choice is less than 0, well, in this case, you typed an invalid number, you lose. But that's not all that we have to do. If we hit run and we again type some extraordinarily large number, you'll see that it still says computer chose 1, you win. What's going on? We have this statement that should catch this situation, but it's right at the bottom. So it's not going to be checked until one of the previous ones are checked. Namely, it's one of these that's going to be the problem. So what we have to do is we have to move this statement above all the lines so that we first check if the user choice is greater than 3 or less than 0. And if that's not true, do we actually continue checking to see who won the game? Now, finally, we can run our code, type an invalid number, and get you typed an invalid number, you lose. So now that we've actually got our logic all sorted out, the next step is to include our images. And to do that, we have to somehow match it up with these numbers we have, right? 0, 1, and 2. Now, there's many ways that you could do this and you could solve this project, but the easiest way is probably putting the game images into a list. where we have rock as the first one, paper as the second one, and scissors as the last one. So we're using the fact that lists have a order that is always going to be followed. So we can now get hold of the rock picture by getting game images 0. We can get scissors by doing game images 2, and so on and so forth. And we can match those up to our choices, the user choice and the computer choice. So when the user chooses a number, then we're going to print from the game images, and we're going to use our little square brackets to select the image we want from this list. And the one that we want is going to be based on the user's choice, right? 0 for rock, 1 for paper, 2 for scissors. So we're going to put user choice as the index to pick out an image from game images. Now, down here for the computer choice, instead of printing the number that the computer chose, I'm going to delete that and add a little colon. So that way it's going to show computer chose, and then I'm going to print the image of the choice that the computer made. So I'm going to add another print statement. I'm going to tap into the game images, and then inside some square brackets, I'm going to use the computer choice, which is going to be between 0, 1, and 2, as the index to pick out the corresponding image from my list game images. So now we're finally ready to run our code, and I'm going to choose 0 for rock, and the computer chose paper. So paper beats rock, I lose. Let's try this again. I'm going to choose scissors, and computer chose scissors, it's a draw. But we have also introduced a bug. So if we test this using a number that's outside of this range, 0, 1, or 2, so let's try 5, and we hit enter, what do we get? We get a index error. So what has happened here? Well, this is up to you to debug. Well, this is a really good opportunity for you to practice your debugging. So think about what has changed since the last time we tested this and how you can fix the code so that it works as expected. So telling us that you typed an invalid number, you lose whenever we type a number that's above or equal to 3 or less than 0. So I want you to pause the video and see if you can debug this challenge so that when you type in 5, you get this printed. Pause the video now. All right, so what's going on here? Because we tested this and it worked, but in between that time, we also added this line because we wanted to get hold of the game images based on the user's choice. Now at this point, the user's choice is unchecked by the if statement. So it could still be equal to 4 or 5 or 10 or a million. So if in that case it tries to get hold of the 5th image from the game images list, well, it doesn't exist. There's only 0, 1, and 2. So to fix this, we need to move this if statement so that it gets checked before this line of code gets carried out. So let's go ahead and cut this line of code out and put it right above this print statement. So in this case, if the user types in a choice that's above or equal to 3 or less than 0, we're going to print this, but else if they typed in any other number, then we want the rest of the code to continue. So let's select the rest of the code, hit tab, and tab it over so that it's included under the else statement. Now let's go ahead and change this from an elif just to an if, because we're no longer checking it as another else if statement. It is just a straight up if. So in this case, if they typed a 5, then it will go into this basket and it will finish there. But otherwise it will go into this basket and it will continue checking later on. So did you manage to debug your code and figure out the issue? This is one of the most important skills as a programmer. You'll have plenty of opportunities coming up to practice your debugging. And if you ever want more practice, head over into the Q&A and see what other students have issues with and see if you can help them out by practicing your debugging skills. now we have completed the project by using everything from lists to randomization to variables to if statements and a whole lot of logic. So how did you get on with this project? If you struggled, this is the time again to go back to it and maybe map things out using a flow diagram, or try to run the code using Thonny to see how it does it step by step. But the important thing is that you got to write your own code and you got to make it work. And this is the only way that you'll understand what's going on so that you can continue on. And as things get harder, you'll be able to learn more because you've already understood all of the previous knowledge. So I hope you had fun with me today, learning and building, and hopefully I will see you tomorrow, bright and early. So that's good night from me for today. Hey, well done for completing day 4. I can see that you're really putting in the repetitions, putting in the practice, and this is what's going to take you really far. Because we all know that programming is not something that you can just learn passively. You can't sit in front of a TV, watch somebody talk about programming, and all of a sudden become a programmer. You have to put in the hours and the effort. It's a little bit like going to the gym, really. You're never going to become muscular and strong if you just watch a bodybuilding show, right? Even, if you watch Arnold Schwarzenegger every day, 8 hours a day, you will never develop those muscles that he has unless you actually hit the gym. So our version of the gym is coding. We're going to hit the coding editor and we're going to type every day until we get it. So have a break, have a rest, and come back tomorrow refreshed, and we're going to put in some more reps and we're going to train you up to become a great programmer.